Somewhere out there in deep space, something exploded in a way that nobody had ever fully recorded before, and even now, scientists still cannot fully explain what it actually was. If this sounds interesting to you, stick around, because we are about to walk through one of the strangest space mysteries uncovered so far. Let's start with some background, just so everything makes sense before we get into the strange part. In the last 6 or so years, there has apparently been a real renaissance in X-ray astronomy, with a sudden wave of new observatories built to study this particular part of the sky, a part that is usually invisible to the kind of telescopes most of us picture when we think of space exploration. Between 2019 and 2024, 5 separate missions were launched by 5 separate space agencies, all dedicated in one way or another to studying X-rays coming from across the universe. In 2019, we got the Rosita mission, whose job was to map the entire sky in X-ray light, which it has apparently done, giving us some of the most detailed X-ray maps we have ever had of the cosmos around us. Then, in December of 2021, NASA and the Italian Space Agency teamed up to launch a joint mission called IXPE, focused specifically on strange, extreme objects like magnetars and black holes, the kind of objects that behave in ways ordinary physics struggles to explain. After that came the Chinese Einstein probe, launched in 2024, along with a similar earlier mission sometimes referred to as LI. Japan's space agency, working closely with NASA, launched a mission called XRISM, mostly responsible for studying hot, glowing gas scattered throughout the universe, and India's space agency launched XPOSat, a mission dedicated to studying X-ray polarization coming from bright cosmic sources, but it is this one mission, the Einstein probe, that seems to matter most for this particular story. It uses a design apparently inspired by a lobster's eye, a wide-field setup that lets it scan huge areas of the night sky all at once, looking mostly for short, bright flashes, the kind of brief events that come and go quickly and are easy to miss entirely with narrower, more traditional telescopes. Now let's get into what this telescope actually found. On March 5th of 2024, the Einstein probe picked up something odd, a source that flashed twice and then faded away, in a pattern that seems to challenge nearly every existing explanation. The first flash lasted around 120 seconds, and the second, weaker flash lasted about 250 seconds, with roughly a 200-second gap of quiet in between. What made this stand out even more was how quickly it faded afterward. In astronomy, how fast something fades often tells us just as much as how bright it was to begin with, and in this case, the X-ray brightness apparently dropped off within just 2 days, which is extremely fast. Meanwhile, radio telescopes, including the Australia Telescope Compact Array, picked up a signal from the same location, but that radio signal did not fade for several months. So we ended up with a strange combination, an X-ray flash that disappeared almost immediately, paired with a radio glow that lingered for a very long time. Put together, that pattern does not seem to match anything scientists had documented before, and there is apparently no clean physical explanation for it yet. All we really know is that whatever produced it had to be extremely powerful. To try to understand what actually happened, researchers went through the process almost like detectives, carefully comparing this event against every known type of cosmic explosion and slowly crossing options off the list one by one based on how each one is supposed to behave. First, they considered a tidal disruption event, which happens when a black hole tears apart a star or some other unlucky object that wanders too close. These events do happen fairly often across the universe, and they do produce some fairly dramatic effects, but they usually fade over months or even years, producing a very specific brightness curve that looked nothing at all like what was seen here, so that explanation was fairly quickly ruled out. Next came X-ray binaries, systems where a black hole or a neutron star slowly feeds on a companion star nearby and occasionally produces a burst of X-rays whenever it takes in too much material too quickly, almost like it is overeating. These bursts can be relatively brief, sometimes lasting only a short while, but they rarely come paired with a strong, long-lasting radio signal like the one observed here, so that possibility did not really fit either. Then they looked at stellar flares, sudden bursts of energy released from stars, sometimes even from stars fairly similar to our own sun. Our sun does produce flares like this from time to time, and some distant stars are known to produce much bigger versions called superflares, but the radio emission coming from a typical stellar flare usually only lasts a few minutes or maybe a few hours at most, not several weeks, which is what was actually seen here, so that possibility was also crossed off the list. Magnetars were considered too, since they are already known for sudden, violent explosions of their own, but magnetar flares typically peak and fade away in under a second, which is far too quick to match the timeline that was recorded here. That left essentially one possible explanation that still somewhat fits the overall pattern, even if not perfectly, and that explanation is a gamma-ray burst. Gamma-ray bursts, or GRBs, are among the most powerful explosions known in the universe, usually produced when a massive star collapses and releases a huge amount of energy through fast-moving jets, or sometimes when two neutron stars collide. The double flash pattern seen here is actually very common in gamma-ray bursts, and almost all gamma-ray bursts are followed by a long fading radio afterglow caused by fast-moving jets slamming into surrounding gas, which does seem to match what was observed here too. Except there was one major problem with this explanation. No gamma rays were ever detected from the source. This event only showed up in X-rays and radio light, nothing in gamma rays at all, which essentially makes it a gamma ray burst without any gamma rays. Researchers behind the paper are apparently calling this a gamma ray dark transient, seemingly the first event of its kind that produces no gamma rays but still behaves like a gamma ray burst in every other way. That is genuinely puzzling, because current models suggest these events should be so powerful that gamma rays basically have to appear. So why might this particular event have skipped gamma rays entirely? And what does that actually tell scientists about how these violent explosions really work underneath the surface? One idea floating around is that the jet producing this event might simply be pointed slightly away from us, something scientists call an off-axis jet, meaning the gamma rays could be aimed somewhere we simply cannot see from Earth, while the X-rays still manage to reach us at a wider angle. The problem with that particular idea is that it does not fully explain why we see absolutely no gamma ray signal at all, since something, even a weak trace, should technically still leak through toward us if the geometry were only slightly off. Another possibility, and one that seems to hold up a bit better, is that the jet itself never fully developed in the first place. In this scenario, a collapsing star tries to launch a jet outward, but that jet simply does not have enough raw energy behind it to punch cleanly through the star's thick outer layers, so instead of breaking free and producing gamma rays, it stalls partway and produces X-rays instead, almost like a choked or smothered version of a normal gamma ray burst. A third idea points instead to the makeup of the jet material itself, suggesting it might be loaded with unusually heavy matter, which could slow the jet down considerably and make efficient gamma ray production far less likely to happen at all. Put together, the most likely explanations all seem to point towards some kind of unusually weak or inefficient gamma ray burst, though nobody working on this can say for certain yet, and more data will apparently be needed before anyone can settle the question. It is even possible this is something entirely new, a type of object we have simply never seen before, and that would not be without precedent. It was only about a decade ago that researchers discovered fast radio bursts, brief flashes of radio energy possibly linked to neutron stars or magnetars, and even now, scientists still do not fully understand what causes them. So discovering a genuinely new kind of explosion is not really that far-fetched. Interestingly, and perhaps not surprisingly at this point, this was not the only strange event this same telescope has picked up recently. Just 2 weeks later, it apparently caught another unusual explosion, this one much farther away, at a redshift of 4. In that case, the X-rays and gamma rays arrived at noticeably different times. Normally, scientists expect both to arrive close together, since gamma rays are thought to form first, but here, X-rays were detected for at least 17 minutes, and seemed to arrive roughly 6 minutes before the gamma rays did, something that has apparently never been seen before. This all matters quite a bit, because it directly challenges how scientists currently think gamma ray bursts form, and how collapsing stars behave in their final, most violent moments before they die. For a long time now, the models describing these kinds of explosions have been treated as fairly well understood, at least in broad strokes, something astronomers felt reasonably confident about, but events like this one suggest there are still major gaps hiding underneath that confidence. Discovering an explosion that behaves like a gamma ray burst in almost every single way, except for the one detail that technically defines what a gamma ray burst actually is, forces scientists to go back and reconsider assumptions that had held up reasonably well until now. It is a genuine puzzle, and puzzles like this tend to push a field forward because they force researchers to build better, more flexible models instead of relying on older ones that clearly do not cover every case. It also shows just how valuable these newer X-ray telescopes have quietly become for modern astronomy. Missions like Rosetta and the Einstein probe are allowing astronomers to study the X-ray sky with a level of precision that simply was not possible even a decade ago, revealing an entire hidden layer of violent, fast-moving events that older telescopes were apparently just not sensitive enough to ever catch. Some of the newest, most detailed X-ray maps of our own galaxy, the Milky Way, have come directly out of this same recent wave of missions, giving scientists a much clearer picture of what our galactic neighborhood actually looks like in this invisible part of the spectrum. The bigger takeaway here is that even with everything we already think we know, the universe still seems to be far more complex, far more layered, and far stranger than our current models tend to suggest. These new instruments, nearly all of them built within roughly the last 6 years, keep turning up bizarre, atypical explosions that simply were not visible to us before now, and as more of these strange events get discovered and studied in detail, they may eventually help resolve mysteries that have apparently been sitting there undetected the entire time, quietly hidden just outside the reach of older, less sensitive technology. For now, this remains an open case. A violent flash of X-ray light paired with a lingering radio glow and a question mark sitting right where the gamma rays should have been. Somewhere out there, whatever caused this is apparently still waiting to be fully understood, and honestly, that sense of not quite knowing yet is part of what makes it so fascinating to follow along with. Space has a habit of doing this, showing us something that almost fits an old explanation and then quietly refusing to fit it completely, leaving just enough room for a new idea to eventually take shape. Maybe future observations will settle this particular case, or maybe it will stay a little mysterious for a while longer. But either way, it seems like a good reminder that there is still plenty left out there for us to figure out, one strange flash of light at a time.